in software project management. The topic is network planning models. Network planning models introduction. These project scheduling techniques model the project's activities and their relationships as a network. In a network, time flows from left to right. The two best known being CPM, critical path method, and PERT, program evaluation review technique. Both of these techniques use an activity on arrow approach to visualizing the project as a network, where activities are drawn as arrows joining circles or nodes which represent the possible start and completion of an activity or set of activities. More recently, a variation on these techniques called precedence network has become popular. This method uses activity or node networks where activities are represented as nodes and the links between nodes represent precedence requirements. This later approach avoids some of the problems inherent in the activity on arrow representation and provides more scope for easily representing certain situations. It is this method that is adopted in the majority of computer applications currently available. These three methods are very similar, and it must be admitted that many people use the same name indiscriminately to refer to any or all of the methods. So the figure represents the IOE maintenance group accounts project activity network fragment with a checkpoint activity added. And this figure represents the IOE maintenance group accounts project activity network fragment represented as a CPM network. Formulating network model. The first stage in creating a network model is to represent the activities and their interrelationships as a graph. In activity or node, we do this by representing activities as links. In the graph, the node circles representing the events of activities starting and finishing. Formulating a network model. The first stage in creating a network model is to represent the activities and their interrelationship as a graph. In activity or node, we do this by representing activities as links. In the graph, the nodes representing the events of activities starting and finishing. Constructing precedence networks. A project network should have only one start node. The project network should have only one end node. A node has duration. A node represents an activity, and in general activities take time to execute. Links normally have no duration. Precedents are the immediate preceding activities. Time moves from left to right. That is fragment of a precedence network. Code, data, take on, program test, install. And this figure represents a loop representing an impossible sequence. A network may not contain loops. Figure demonstrates a loop in a network. A loop is an error in that it represents a situation that cannot occur in practice. While loops in the sense of iteration may occur in practice, they cannot be directly represented in a project network. A network should not contain dangles. A dangling activity such as write user manual in figure should not exist, as it is likely to lead to errors in subsequent analysis. Redraw the network with a final completion activity, which, at least in this case, this is probably a more accurate. A dangle. And another figure is resolving the dangle. Design program, code program, test program, install program. Write user manual. So here, write user manual to sign off. Representing lagged activities. We might come across situations where we wish to undertake two activities in parallel so long as there is a lag between the two. We might wish to document amendments to a program as it was being tested, particularly if evaluating a prototype, where activities can occur in parallel with a time lag between them. We represent the lag with duration on the linking arrow as shown in the figure. This indicates that documenting amendments can start one day after the start of prototype testing and will be completed 2 days after prototype testing is completed. Indicating lags: build prototype, test prototype, revise specification, document amendments. Thank you.